Right. Good afternoon, all of you. You can able to see the screen. That is angle of contact. The heading angle of contact. So, as part of the surface tension, the next topic we need to discuss about angle of contact. Angle of contact. So, what is this angle of contact? To understand this angle of contact, first let us consider a container. A container, within that you can fill the liquid. This is the container, you can imagine. It's like a glass shaped container. Now you can fill the water. Suppose instead of glass, you can take a tumbler. Either you can take a solid tumbler like metal or wood. Then you can observe the endpoints of this tumbler at the free surface. The free surface you can see here, the blue shape. The free surface of the liquid will be like this, water, with respect to the tumbler. That means the sides edges will be wetting. Wetting will be takes place. That is one observation. And the liquid surface also you can observe like this, in a concave shaped manner. It is filled with water. Suppose you can fill with mercury. You can fill with mercury in a tumbler or in a glass, whatever. Then the shape of the mercury will be like this, in a convex shape, bulged shape. The top surface of the mercury will be like a bulged shape. So this is the difference you have to observe. One is like a concave shape, other one is like a convex shape. Are you clear this point first?
Sir,
Mercury. In the case of mercury liquid form, is in the case of water. So the free surface of the liquid is like this. Sometimes concave, sometimes convex. That means that depends on the type of liquid that we have taken. So based on this, now we can define the angle of contact. Angle of contact. Why it is happen? All this we'll discuss step by step. Why this concave shape will come for water inside a tumbler? For mercury inside a tumbler, why it will become like a convex shape, the free surface of the liquid, that we need to understand. So now the angle of contact is defined as the angle between tangent to the free surface of the liquid. Tangent to free surface of the liquid and solid surface inside the liquid. Inside the liquid is called angle of contact. I repeat once again. Angle of contact is defined as angle of contact is the angle between the tangent to the free surface of liquid and solid surface inside the liquid. What is the tangent to the free surface? You can see our free surface I have taken. One is like a concave shape, other one is like a convex shape. Suppose you can take tangent to this concave. This is the diagram. You can see here this is the tangent to the concave. Yes or no? Are you able to see the tangent arrow symbol?
yes, sir.
Yeah, that tangent to the concave shape. Now, what is the angle? This is the angle. This is, let us say, theta. See here, this is the solid, you can imagine. This is the solid tumbler. Then at the point of contact, the angle between solid and tangent to the free surface of the liquid. Okay. So this angle you can see here in this case, in the water case, the theta is less than 90. Theta is less than 90. Whereas if you draw the tangent here, in the case of mercury, so you can see a tangent to the free surface of the liquid. This is the tangent. Okay, from the point of contact. That means at the point of contact. This is the point of contact of the liquid with respect to solid. Then you can see this angle. Again, inside the liquid only should take this angle from the solid to free surface of the liquid, tangent to the free surface. This is theta. Then this theta will be greater than 90 up to this angle. Are you clear these 2 points? theta less than 90 and theta greater than 90, right? So you can see the angle of contact is the angle between the tangent to the free surface of the liquid to the solid surface inside the liquid at the point of contact. Inside the liquid at the point of contact is called angle of contact. Is called angle of contact. Okay. So this angle of contact differs with respect to the liquids and the solid that is contained. So how it is changing and what is the values? Suppose you can take cases. Case 1, for pure water and perfectly clean glass. For pure water and perfectly clean glass, you can take perfectly clean glass. Then the angle of contact is 0. Then angle of contact is 0. Then how it is like this? For pure water, you can take. This is the perfectly clean glass. Inside this, you can take pure water like this. Then angle of contact is 0 means actually this free surface actually it will go like this. Tangent to the free surface it will go like this. Almost parallel to the solid. Okay. Either it won't go concave or convex. So it won't touch actually at the end points. That is about for pure water and perfectly clean glass. So this makes theta 0. That means outside I have taken, you can take inside the tangent you can take inside pure water and perfectly glass. So this tangent like this inside. This theta inside is 0. Tangent. Second case is that for pure water and pure silver. Pure water and pure silver. So that means you can take silver is the metal. In that you can fill the water. Then in the silver, the water is exactly horizontal level. Horizontal level. Then the tangent is like this. And the angle is 90. 90 degree. Then theta is 90. Yeah, theta is 90. Then for water and greased glass. Next third case. Glass connected with grease. Glass with grease inside. Grease material. Okay, there is a glass inside, some grease is there on the sides of the glass. Grease material. And after that, inside water I can fill. That means in that case, the water will be like a convex shape. Then the tangent it will go like this. Then the theta will be greater than 90. Or else you can take a mercury inside the glass also. The mercury will not contact with the glass. Then it will go like a tangent like a red color, this one. Then theta is greater than 90 in this case. Okay. So these are the different cases where angle of contact will be 0, 90 and greater than 90. So what is the reason for this? What is the characteristic property that angle of contact depends on what factors? Angle of contact depends on what factors you can see. Angle of contact depends on the nature of the liquid and solid pair. The nature of liquid and solid pair. That means what solid material, what tumbler material you have taken, and what is the liquid that you have poured into the tumbler. So that is the nature of the liquid and solid pair. Next point is that the medium above the free surface of liquid. The medium above the free surface of liquid. The medium above the free surface of the liquid. Next point, the temperature of the liquid. The temperature of liquid. And next point is that impurities added in the liquid depends on the amount of impurities added in the liquid. Are you clear this? The angle of contact depends on nature of
Sir.
pair of liquid and solid and the medium above the free surface of the liquid. Normally, medium above the free surface of the liquid, what you can say? Air medium in general. Other than air medium, the angle of contact will be definitely changes. Then the temperature of the liquid and impurities added in the liquid. So the temperature and impurities you can see clearly. If the temperature increases, what happens? The temperature increases, angle of contact decreases. Okay. If the temperature increases, the angle of contact will be decreases. Why? Angle of contact decreases. Why? Because if the temperature increases, surface tension decreases. Surface tension decreases. This is the point you have to understand. Okay, if the surface tension decreases, angle of contact decreases. Next, amount of impurities added. Impurities. If the impurities are added, impurities are again two types. Completely soluble or partially soluble. Partially soluble. Partially soluble like detergents. If we add detergents to the liquid, let us say water, what happens? Normally, can you add detergents everyday life for removing the stains on the cloth? Okay. So, partially soluble means you can add detergent. If you can add detergents to the liquid like water, then detergent will be partially soluble and it will make surface tension of water decreases. ST of water decreases. ST of water decreases means angle of contact also decreases. Angle of contact decreases. Are you clear this point? If you add detergent to the water, then surface tension of the water decreases, then angle of contact decreases. So the main point why stains are removing, this is the application also actually. When the detergent added to water, then only the stains are easily removed from the cloths. Okay, are you clear this point? Why? Because surface tension of the water decreases, that is one point. When the surface tension of the water decreases, then the water molecules along with the detergent molecules will go into the stain point, that means inside the cloth. Then they will take these molecules will take the stain molecule and bring back that stain molecule out of the cloth. Suppose if the surface tension of the water is normally somewhat high, in that case it won't touch the cloth inside stain, then in that case stain will not come back. Are you clear this point?
Yes.
Yeah, this chemistry also it will come, this concept. Okay, there will next you'll see perfectly soluble. If you can take a completely soluble instead of partially soluble, you can take completely soluble mixture into the water. Completely soluble means, for example, salt, sodium chloride. Sodium chloride is the salt completely soluble. Then if it is perfectly or completely soluble, then what about the surface tension? Here perfectly soluble means surface tension increases. Surface tension will be increases. So angle of contact also increases. Angle of contact also increases. Okay. So this is about, for example, NaCl. In that case, it is perfectly soluble in water. Then in this case only, angle of contact will be increases. Keep in mind. Okay. So this is about understanding about impurities added to the liquid like water. Then how the surface tension changes and the angle of contact will be changes. Are you understood up to this?
Sir.
Right. So normally for a tumbler, I said vertically I placed. Then we discussed angle of contact. Okay, like this. Perfectly vertically I have taken. Then within this I have taken liquid level. Then angle of contact is discussed. Suppose if you can keep like a tube-like structure and if I keep inclined, if I make inclined like this, some angle of theta. If I make inclination tube, keeping some water or liquid inside the tube, And if the tube is inclined with certain angle, will the angle of contact changes here? Means no. If the tube is, you can keep vertically up or keeping some inclination, even though the angle of contact does not change. Angle of contact does not change. Angle of contact, no change. Keep in mind. Okay, right. So this is about some important points related to the angle of contact and the examples we have discussed. Okay. Now, why this angle of contact is created? Okay, what is the reason behind that? Is the concave shape and convex shape of the liquid meniscus. Actually, the top surface you can call as a meniscus. That you can see shape of the liquid. Next concept will go for shape of the liquid at the free end. That is called shape of liquid meniscus. What is the reason behind this? First, let us consider a concave shape. Based on that, we'll discuss. Okay. So, in that, consider a tumbler first of all. Inside, you can take a water, let us say. Okay, up to certain level, it will be filled. To a certain level, it will be filled. Now, let us consider a free surface of the liquid here. At the free surface of the liquid, let us consider a point. At the free surface of the liquid, let us consider a point which is in contact with the solid surface. Consider a point which is this. Let us say this is the point O. The point O we are talking. At the point O, the liquid is in contact with the solid. Then this point O, that molecule you can call it as a liquid molecule. That red color I taken. Actually, you can take a blue color. It is a liquid molecule. So this liquid molecule is in contact with the solid molecule. Now, what are the forces acting on that liquid molecule? What are the forces? I remember there are two types of forces. I remember. One is cohesive force. Other one is adhesive force. Cohesive force. That let us say FC. Next, adhesive force. Hey, Pandu. Adhesive force. FA. Okay. Now, cohesive force between what? Suppose this is the liquid molecule and inside also liquid molecules. Then the force of attraction. That I am drawing here. There is a force of attraction. That is the FC, cohesive force between the same type of molecules. So what is the cohesive force? The force of attraction between two same type of molecules, FC. Next, adhesive force. The force of attraction between two different type of molecules.
Two different substances.
Two different substances. That means between solid molecule, that is the tumbler, and liquid molecule, water molecule here. Then this is the direction. That is adhesive force. Are you clear this point? FA. You can see here, FA, adhesive force, FC, cohesive force. Okay, why you have done FC like this? Because liquid is inside this level. That means this angle only liquid more is there. So that's why along the liquid direction only I have drawn. Resultant force I have taken. Now for this liquid molecule, let us say mass M is the liquid molecule mass, which is there at point O. Then its weight mg, acting vertically downward. Then third force you can say mg. At point from the point O, what is the next force? mg. This is the mg for the liquid molecule. Are you clear? The total forces acting on the liquid molecule which is in contact at point O. Okay. So then this angle, what is this angle? FC. For water normally, for water inside the tumbler, maximum that angle is 45 degree. This angle theta is 45 degree. Okay. Then FC will be resolved into components. Along the free surface of the liquid, Fc cos 45, Fc cos theta, that is cos 45. And along this resolution of Fc vector into along the tumbler, that is Fc sin 45. That cos 45 sin 45 value how much? Then directly I can write Fc into 1 by root 2. Then what I can say? That value Fc by root 2 na? Yes or no? Fc is cos 45 Fc by root 2. Then Fc sin 45 Fc by root 2. So this is about the values of forces resolved into components. Are you clear this? Now you can define the resultant force. Okay. Now you can see resultant force horizontally and vertically. Horizontally, Fa force outward, but Fc by root 2 inward with respect to the molecule. And mg and Fc by root 2 is the downside. First, horizontally, you can say horizontally the forces on the liquid molecule Fa comma Fc by root 2. Vertically, mg plus Fc by root 2 because both are same direction. The resultant you can take either Fa minus Fc by root 2 or Fc by root 2 minus Fa. Depends on the value. Okay. For that you can take case study. Suppose case 1, if Fa greater than Fc by root 2. That means adhesive force is greater than 1 by root 2 times of coercive force. Then what about the resultant force? The resultant force will be F net horizontally Fa minus Fc by root 2. What is the direction? Outward direction, like this. So you can see here, similar type, you can say this is the point O, then this resultant. Let us say F1, F net 1, F1. And one more force, what is there here? Mg plus Fc by root 2. Mg plus Fc by root 2. Are you clear this? The total force on this molecule is F1, that is Fa minus Fc by root 2, and Mg plus Fc by root 2. Then resultant of these two vectors, what you can get? Resultant of these two vectors will get is outward, like this it will get. Yes or no? It will get outward direction, resultant. So this is the Fr, resultant force. Okay. Then if it is the resultant force acting on the molecule, then how the molecules will behave? Then how the molecules will behave means tangent to the resultant force. The direction of the resultant force is the surface tension will behave like a tangent to the resultant force. That means if you draw the tangent here, that means perpendicular to the resultant force. If you draw perpendicular to the resultant force here from point O, like this. This is the perpendicular to the resultant force. That will give the tangent. That means now in this case, the shape of the liquid will become concave in shape. The tangent, how it is like this? Tangent is like let us say point O to point S. This is the direction. Tangent, that means perpendicular to Fr. Okay, this is the surface tension direction. Then the shape of this will become like a concave. Okay, are you clear this? Why it will become concave shape means this is the reason. The resultant force acting on the molecules will depress the liquid slightly. Will make the depression from end points to middle points. So that the liquid at the end points, because of the distance is more at the end point, that means in contact with the solid. So it is connected with the solid surface. Remaining molecules slowly it will change like this. Are you clear this? First case 1, why it is concave shape? Based on the resultant force what we discussed. Okay, in the case of Fa is greater than FC. Suppose if it is FA is less than FC, if FA is less than FC by root 2. In that case, again you can draw the resultant. This is the surface you can take, and there is a molecule in contact with the solid. So let us say this is the molecule, which is the red color, point O. Now horizontal forces you can draw now at this point. See, this is the direction of FA, and inward is FC by root 2. Okay, now resultant is FA minus FC by. That means FC by root 2 minus FA is greater than 0. That means let us say F1, that is FC by root 2 minus FA. Then here resultant F1 like this towards into the liquid. And downward force is there always, mg plus FC by root 2. Now in that case, what is the resultant force? The resultant force is like into the liquid. This is the FR. Resultant of F1 plus mg plus FC by root 2. This FR is into the liquid. Now you can draw the tangent to the surface, tangent to the FR. That means perpendicular to the FR. A tangent perpendicular to the FR you can draw. Then a tangent perpendicular to the FR, it will go like this. Tangent O to S is the surface tension direction. In that case, the liquid will be like a convex in shape, like this. Liquid is like a convex in shape. Convex. Okay. When FR is inside the liquid, in that case, what is the point you have to understood? Liquid does not wet. Liquid does not wet the solid. Liquid does not wet the solid. This is very, very interesting point. Whereas in the previous case in the concave, liquid makes the wetting of solid. Liquid makes wet the solid. Example for above case is water. Water in a tumbler will make wetting of solid. The convex shape is that liquid does not wet the solid. Example for this is that mercury. You observed anytime mercury does not wet the solid surface. Mercury does not wet the solid surface. Okay. So this is about understanding about the convex shape and concave shaped meniscus. Okay, free surface of the liquid. Next, third case, if FA is equal to FC by root 2. If FA is equal to FC by root 2. Then in this case, what happened? You can see here, again this solid surface you can take. There is a point, liquid molecule, away FA, into the inward is FC by root 2. If both are equal, what about F1? F1 is equal to FA minus FC by root 2. That is equal to 0. Then F1 is 0. That means there is no horizontal force. Then only vertical force. What is the vertical force? mg plus on the molecule, liquid molecule, mg plus FC by root 2. Are you clear this? There is only vertical force, that is mg plus FC by root 2. In such a case, the resultant force also FR like this, vertically downward on the liquid molecule. The resultant force is vertically downward on the liquid molecule, like this is the resultant force FR. Then from point O, that the perpendicular you can draw like this, OS. Then how the liquid surface is like a horizontal. Okay, liquid surface like a plane surface. Plane surface. Are you clear this? Liquid surface will be like a plane surface. So this is about understanding about phenomena of free surface of a liquid meniscus inside a small tube, inside a small tumbler. Within that, the phenomena of concave shape and convex shape and a plane shape of the liquid based on the cohesive forces and adhesive forces acting on a liquid molecule at the point of contact between the solid and liquid. Okay. Now case 1, what is the angle of contact? What is the angle of contact? I said angle between tangent to the free surface OS to the solid surface. That means this is theta here. This theta here less than 90. Okay. Suppose you can take a convex shape. In that case, angle of contact is angle between tangent to the free surface inside the liquid. This is theta. And this theta is greater than 90. In the case of mercury. And here in this case, tangent to the free surface is free surface level and angle between them is 90 exactly. Okay, this is water inside a silver tumbler, a silver container, or a clean glass container. Water inside a silver container or clean glass container, then angle is 90. That means you can expect perfectly plane surface of the liquid without any dip or without any bulged shape. Okay, so this is about understanding about the liquid meniscus shape. Okay, with respect to the liquid and solid. In the case of liquid water, you can take, and for that we have explained based on the phenomena of adhesive forces and cohesive forces. Okay, are you clear this up to? Next we'll go for capillarity. So next we can go for capillarity. Okay, next class we'll discuss about capillarity. Capillarity means there is a rise of liquid. Within a small tube you can take the liquid, sometimes it will rise, sometimes it will fall. Okay, so that phenomena we can discuss as capillarity. Okay, capillarity phenomena. This is about angle of contact and the surface tension that we have discussed. Okay, right. Are you clear up to this? I'll stop here. Okay, thank you, Ananda. It's almost 2 minutes, remaining only 1 minute. Okay, thank you.